Section 2.2, example 6, deriving the formula for the volume of a pyramid. So we know that from geometry, the formula for volume of a pyramid is volume equal to 1/3 A times H, where A is the area of the part, A is the area of like the flat surface that the pyramid sits on. So if the pyramid has a square base, this becomes 1/3 A squared, A being like the size of the sides, or where A denotes the length of one side of the base, and all four sides are going to be the same of the base. So we are going to use the slicing method to derive this formula. And let me get a picture for you guys so you could see it a little bit better. Wow, so pretty. Okay, so what we have here is our pyramid in 3 space. So 1, 2, 3, 4. And we have our cross section here. So cross section is just us being able to slice perpendicular to like whatever axis we're working with. So here, let's do a cross section here. You can see the cross section that they did here. It's a square, and here is another square proportional still to this one right here. Just going a little bit bigger as we keep going forward, just like a pyramid. So slicing method tells us that we could integrate here, since we could make all of these slices exactly the same distance apart, like an infinite amount of slices for this. And we should be able to integrate with respect to whatever our slice is as it gets bigger and bigger. So let's take a look at what they have here. So here we're just integrating the cross section. So just integrating the cross section, we're just going to integrate our area here. So area there is just going to be s squared. So integrating from, let's talk about that a little bit later. But what we're integrating from is from 0 all the way up to whatever this value is over here. And we're integrating that s squared. But we're not in terms of s's, right? We don't really know exactly what these values are. So let's get a good depiction. Let's get some sort of like conversion factor that we could go, because this is all proportional. Like s here is proportional to this a over here, which we know that the height is going to have some sort of proportion to this a. If we just name this other value x, because x is what's moving along here, we could actually integrate that. So let's get that sort of proportion. So s is to, what's another one like s? A. So s is to a, as here we're looking at the height. So s is to a as x is to h. S is to a as x is to h. So now s and a have something in common, and s and x have something in common. All right, there we go. So now s, whatever s is going to be in terms of x, h, and technically now a. Let's get s by itself to see what s is. So let's multiply both sides by a. So we have s is equal to ax over h. A is how wide our cross section is. H is how tall we're integrating over, because the height doesn't really have much to do with like the base, because remember the cross section is only based on the base. So now let's get this and input it here. Remember, we're still with respect to x. So now we're integrating over a certain area. We have ax over h. We're squaring that value. And let's see what our x value is. X goes from 0 to what value? So from 0 to, what stretches out this far? It looks like h does. So x goes from 0 to h. Oh, that makes sense because it's the height. It's that height of the pyramid. Oh, I meant to do this one. It's the height of the whole pyramid. So the whole height of this pyramid, the whole height of this pyramid right here. All right, looks good. So from here, let's factor out that a and the h. because those are just going to be values here. We have our a squared over h squared. We're integrating from 0 to h, integrating x squared. I forgot to write the dx here, with respect to x. All right, and from here, let's just integrate the way that we know how. So x cubed, so we have to multiply by 1/3, integrating from 0 to h. So we have a squared over 9h squared, and we're integrating from h to 0. All right. So from here we have 9 squared over, or a squared over 9h squared. Oh, why did I put 9? That should be 3. 3 times h squared, because this part went to 0, so we're just left with that h squared, or h cubed. And h squared divides out with 2 of those h's, so we're left with a 1/3 a squared h. Oh, which is exactly what they mentioned in the very beginning. So we know the geometry of a pyramid. Volume is 1/3 a h, or a times h. But for a square pyramid, we have this one right here. So we just solved parts of geometry. So if you have any questions, please feel free to ask. Otherwise, bye.